Okay, we're going to be looking at number 15a, numbers 1 through 3 first, and then I'll do 14b, numbers 1 through 3, and 15b, numbers 7 through 9. So just a good mix of everything that we've learned and how to do it. So here on 15 it says, draw each line and estimate the solution. I'm going to save that for the end. The second question is, use the elimination method to find x. If we're trying to find x with the elimination method, then that means I want to eliminate y. Right now, if I added them together, I'd have a positive y and a positive y. That would be 2y. So in this case, I need to first multiply one of these, and I'm going to choose the second one, by negative 1. It doesn't matter if you choose the first equation or the second one in this case, but I just chose the second one. So I'm going to write my first equation, x plus y equals negative 1. Now I'm going to multiply this equation by negative 1. When I do that, I have to make sure that I do the negative 1 to every thing in the equation. So I'm going to multiply the negative 1 3 times. So negative 1 times 2x is negative 2x. Negative 1 times y is negative 1. And negative 1 times negative 4 is a positive 4. Oops, I wrote 1 instead of y. Sorry. Negative y. Okay. Sorry. So negative 1 times 2x, negative 2x, negative 1 times y, negative y, and negative 1 times negative 4 is a positive 4. Now, my elimination method means I just add them up. X minus 2x is a negative x. A y minus a y eliminates. It goes to 0, so it's nothing. And then I'm going to bring my equal sign down right in the same spot, and negative 1 plus 4 is a positive 3. Now here you might be able to see this, or you could add to one side and add to the other, or you could divide by a negative 1, as if there was a negative 1 in front of the x. This will become a positive x, and this side would become a negative 3. So now we have our answer for x. So then number 3 says, use that solution for x to find what y is. When we do this, we can use any equation that we already have. We can use this one, we can use this one, or we can use that one when we multiplied it by negative 1. In this case, I'm just going to go ahead and use this first one because there's no numbers in front of x and y, so it looks a little more simple. So when I do this, I have x plus y. I'm going to plug in this number for x because x is equal to negative 3. So I have negative 3 plus y is equal to negative 1. So again, that's this equation, and I just plugged in negative 3 for my x. Now I want to solve for y, so I have to add 3 to both sides, and I have y equals a positive 2. So my answer should be negative 3, positive 2. Now I'm going to graph them and find out. I'm going to graph this one first, and when I do that, it would be easier if it was in slope-intercept form. So all I have to do is subtract x from both sides. So I have x plus y equals negative 1. If I subtract an x from both sides, I now have y is equal to negative x minus 1. So I start at negative 1, and a negative x means I go down and over, or I can go up and backwards, up and backwards. And I get, oops, a line through there. And now I can graph this one. And when I do this one, I also want it in slope-intercept form. So right now it looks like this. I'm going to subtract the 2x. So now I have y is equal to, if I can leave it in this order, negative 4 minus 2x. I just have to remember that what's in front of my x is my slope, and what's over here is my y-intercept. So my y-intercept is negative 4. 1, 2, 3, 4. and then I'm going to go down 2 and over 1, or I can start here and go up 2 and backwards 1, up 2 and backwards 1, up 2 and backwards 1. And now I can draw my line. And if I'd drawn my blue one bigger, I would have seen this is my point of intersection, which is 1, 2, 3, negative 3, positive 2. And that's right. On 14b. So this was from last week, but there were a couple kids who did not turn in their 14, so I'm going to do it real quick, and hopefully that will be helpful to you. Please go back and do all the worksheets. Even if they're turned in late, you will get some credit, so please go back and try them. Okay, this is a little hard to see. This is actually number 1 through 3, and so then this x is part of the equation. Okay, I'm again going to save it to graph until the end. So now we're going to use the substitution method to find y. So what they're meaning is, if we're going to find y first, we want y in the equation. So we want x by itself, and we're going to substitute in. So to get this x by itself, I'm going to subtract y from both sides. And here it'll go away. And so I'm going to have x is equal to 1 minus y. Now I'm going to use this equation, and where I have this x, I'm going to plug in this, because from my first equation I said that x was equal to 1 minus y. So now in the second equation I can plug in what x is equal to for that x. I just keep changing colors, so hopefully we can match things up. So this equation right here is y equals x plus 3. And this x is this right here, so I'm going to put that in for that x. So now I have y is equal to 1 minus y plus 3. I'm going to add the 1 and the 3 together first. So I have y equals 4 minus y. And now I want the y's on the same side. So I'm going to add this y to the other side. So over here it goes away, and I have 4 is equal to 1y and another y. So that's 2 y's. To get y all by itself, I need to divide that 2. So now I have y is equal to 4 divided by 2 is 2. So that's how we use substitution to solve for y instead of solving for x, which is what we always did in class. So if you want to solve for y, then you want y in the long part of the equation, and you want the other variable on the other side by itself. Then you plug in that other variable, and the x goes away because we've used it. And then we solve for y. Now the last part is to solve for x based on what we have for y. So now we have a number for y, and we can go back to any of the equations and put that y in and solve for x. So I could start with the x plus y equals 1. I could use the y equals x plus 3. I could even use this one down here that we've already rearranged. And usually that's a good one to use because x is all by itself. So we won't have to move anything around on the other side of the equation. So if I use this one, x is equal to 1 minus y. I'm going to say y is equal to 2, so x is equal to 1 minus 2. 1 minus 2 is the same thing as negative 1, so x is equal to negative 1. And we're done. This is my x, this is my y. Now let's check it. So the hard part of checking it is just having it in the right form. So this red one is already in y equals x plus 3. So I can do that. My y-intercept is 3. My slope is just a positive 1, so up 1 over 1. And I can draw a line on that. Okay, and then the other one, I'll do it in green right here. So we had this one right here, x plus y equals 1. I know I've written all over it. X plus y equals 1. We want it in slope-intercept form, so it's easy to graph. So we're going to move the x over. We have y equals, I'll put the x first, so negative x plus 1. Now we can see that positive 1 is our y-intercept, and our slope is negative 1. So down 1, forward 1, down 1, forward 1. Or we can go up and backwards, up and backwards. We draw that line through here. And we can see that our intersection point is right here, which is negative 1, positive 2, negative 1, positive 2, and we are right. So this is why we still are graphing it, just to double check your math and to make sure that you're substituting in correctly. All right, last one is 15b, numbers 7 through 9. Again, I'm going to save the graph for last. We're going to use the elimination method to find x. If we're looking for x, that means we want x in the equation. It means that we want y on the other side by itself. Except, no, that was for substitution, sorry. It means we want to eliminate y. So if we want to find x, that means we want to eliminate our y. So here, if we were to line up these equations, we have 3x plus 2y is equal to 5, and we have x minus y is equal to 0. If we add these up, we get a y and we get a 4x. So that won't work. So what we're looking for when we want to eliminate y is to make the number in front of y the same in both equations and to have one positive and one negative. So we're going to ignore whatever is the x. If we want to eliminate y, it needs to be the same number and opposite signs, because then when we add it together we get 0. If this one's already 2 and this one's already negative, then all we need to do is multiply this equation by 2, because now the y will be a negative 2y. And you see, when we have that, then it'll be the same number and opposite signs. So I'm going to rewrite the top equation. And then if I multiply everything in this equation by 2, remember it goes to the x, it needs to go to the y, and it needs to go to the 0. So 2x, and this was a minus y, so now it's a minus 2y, and 0 times 2 is 0. Now when I add them up, my positive 2y minus 2y will cancel out, and it will be eliminated. 3x plus 2x is a 5x, and 5 plus 0 is 5. 5x equals 5. We're going to divide by the number in front of the variable. So we're dividing by 5, and we have x equals 1. Now we want to use one of these equations to find what y is. I always like to go with what looks the simplest. So this one here looks the simplest. If I start with x minus y equals 0, and I plug in 1 for x, I have 1 minus y equals 0. Now at first you might say, well, it's 0, I don't think there's anything. Just keep going. We would normally try to move the y over and get it by itself, so plus y and plus y. I have 1 left, and I have 0 plus y. Well, 0 plus y is just y. So now 1 equals y. Doesn't matter if it's forwards or backwards, this is the same thing as y equals 1. And so our point is our x and our y, and that's it. So now let's go through and graph this one. To graph it, we have to put it in slope-intercept form. So we'll go down here, we want the y all by itself. So we're going to subtract the 3x, and then that makes positive 3x and negative 3x makes a 0. So now you're adding 0, and that really means you're adding nothing. So we have 2y is equal to negative 3x plus 5. So it doesn't matter which order I put these as long as I keep that negative with the 3x. Okay, we want y by itself, so we have to divide everything by 2. And I mean everything, so don't forget this last one either. The 2 divided by 2 makes a 1 in front of the y, so now we just have y by itself. This does not divide evenly, so negative 3 halves times x. And this one doesn't divide evenly either, so we're going to leave it as a fraction, 5 halves. Okay, so to graph that, I go up 5 halves. So this is 2 halves, this is 4 halves, and then halfway in between is 5 halves. Now I need to go on my slope negative 3 over 2. So I'm going to choose to go down first. So I'm going to go down 3. Since I started in the middle of the grid lines, just stay in the middle of the grid lines. So down 1, 2, 3, and forward 1, 2. So I should be in the middle of the grid lines because that's what I started with. If I was really good, I could use a ruler and connect this, but I'm not that good. So I'm going to go up and backwards now. So up 1, 2, 3, and backwards 1, 2. Okay, now I think I can draw a line from this. All right, let's graph our last one. It was x minus y equals 0. I still want y by itself. So usually I'd move the x over, but then I'd have a negative y. I'm going to get smart, and I'm going to add y to both sides. So I'm going to move the y over. And now I have x is equal to y. And if I like it better, I can write it the other way. Y is equal to x. And I could even say plus 0. There's nothing else there. So if that helps me see, now this is my b and this is my m, which is in front of the x. So my intercept is 0. So I start here, and then my slope is a positive 1. So up 1 over 1. And then I can make that line. Okay, and now we can see our point of intersection right here is 1, 1, which is exactly what we got here, so we were correct. Alright, thanks for watching the video, and I will see you guys on Monday.